All right, good afternoon, ladies and gentlemen. We're going to be doing a sample problem here, problem number 37. This is on relative velocity. So the problem states Huck Finn walks at a speed of zero point 0.6 meters per second across his raft. Okay, and there's a diagram here in the book here, and maybe we'll just show it to you quick. It looks like Huck Finn's walking across the raft, walking across the shore, and we've got a raft moving, and we've got the river moving. So let's begin with our first of the problem-solving steps. That is drawing our diagram. So here's our raft. Here is Huck Finn, right? And it looks like Huck Finn is walking perpendicular to the river. So that looks like he's walking this way. Then we do have a river, and the raft is moving downstream. So the whole raft is moving this way. Now, I always like to kind of define my coordinate system here. So when I talk about variable 1 here, I'm going to be talking about Huck Finn. All right. By 2, I'm going to mean the raft. And by 3, I'm going to mean the shore. All right. So, and the big idea here goes something like this. If you have more than one reference frame, the velocity of object 1 relative to 3 is equal to the velocity of 1 relative to 2 plus the velocity of 2 relative to 3. So for instance, in this problem, what that means is the velocity of Huck Finn relative to the shore, which is what we want to know, is equal to the velocity of Huck Finn relative to the raft plus the velocity of the raft relative to the shore. All right. Now the problem states that Huck Finn walks at a speed of 0.6 meters per second across his raft. So that would indicate that the magnitude of vector 1, 2 here, these two lines mean magnitude, is 0.60 meters per second. All right, got those units in there. Now it also says that the raft is traveling down the Mississippi River at a speed of 1.70 meters per second relative to the shore. So the raft relative to the shore is moving at 1.70 meters per second. Okay, now what is Huck's velocity relative to the shore? So what is v13? Well, I can't just add these up. These are vectors, so I'm going to have to draw a vector diagram here. So it looks like Huck is walking perpendicular to the shore, all right? And if I'm going to add to that vector 2, 3, remember when you add vectors, you put them head to tail, okay? So my resultant vector, v12 plus v23, is going to look like this. All right. So this would be v13. So how am I going to find the magnitude of v13? Well, since this is perpendicular, I can assume this is a right angle here. And I could say that at least the magnitude of v13 would be equal to the square root of the magnitude of v12 squared plus magnitude 2, 3 squared. So just a little Pythagorean theorem here. So v13 then is going to be equal to the square root of 0.60 squared plus 1.70 squared. And if I type that into my calculator, I would get, it looks like 1.80 meters per second. So that would be the speed of Huck Finn relative to the shore, or relative to the bank, relative to the river bank here. By shore here, in the context of the problem, we mean relative to the river bank. Now, we're not done yet. The problem also asks what's Huck's velocity, speed, and direction relative to the riverbank. So we kind of have to find an angle here that we want here. It wants to know the velocity relative to the riverbank. So if I draw that in here, it looks like they are looking for angle theta here. So the velocity relative to the riverbank. Well, what is that angle? Well, so since this is a perpendicular, we could assume this angle is the same as this angle here because of alternate interior angles. So what is theta? Well, I know all three sides of this triangle, so I could use any trig function I wanted to. So I'm going to use tangent, just because I like tangent. So if I look at that triangle, I would say tangent theta is equal to the opposite side over the adjacent, right? TOA, right? Opposite over adjacent. So that would be V12, of course, magnitude over V23, all right? So in other words, tan theta would be equal to V12, which we said was 0.60 over 1.70, right? And we're looking, so theta would be the inverse tangent of 0.60 divided by 1.70. I'm out of room here, and it looks like then theta would be, if we enter that in our calculator here, we get about rounded 19 degrees, okay? And again, this is relative to the riverbank. All right, that's problem 37. And as a reward for your hard work here, you get to see something that'll hopefully make you laugh a little bit. Oh, a senior picture of Mr. Kirsten. Oh, look at that. Notice the backlit lighting of the mullet. Oh, what good stuff. Good stuff. All right, nice work, physicists. Nice work.